I got another question about the force velocity curve, and then specifically uh, the next slide. So you guys should be pretty familiar with the force velocity curve uh, from this past week in lab as well. But again, the idea is that the lower the force that must be produced, of course, then is going to um, the lower the amount of force that we have to produce, the faster we're going to be able to produce that force, right? As we start to move along this curve and we have to increase the amount of weight or force that we're going to have to produce, the slower we move that up until the point where we essentially can't move the weight, but we're still able to hold it, which is our isometric, or I've even termed it the maximal isometric contraction. And then when our velocity goes in the negative direction, that's of course because it's going in the opposite direction of our force. It's known as a lengthening contraction because it's more force than we're generating, and our muscles are then undergoing an eccentric contraction, which allows us to generate significantly more force for a couple primary reasons, mainly because of um, uh, the elastic properties of muscle. So the connective tissue there adds some force, um, as we kind of visualized in lab, kind of the ripping of actin and myosin apart. So we kind of have that idea. Again, the concept as far as looking on the concentric part of this is the amount of weight that you're trying to move will ultimately determine how fast you can move that weight. So if we jump to the next slide here, uh, so if we jump to the next slide, sorry for the delay. So if we then look at the training specificity, sorry for the delay, was trying to use a pen to be able to draw, but that's not working very well at the moment. There we go. So there's my pen back. So the idea of training specificity essentially describes the phenomenon that however we train, the adaptations that are going to respond in a manner that is consistent with the type of training in which we did, right? So another way to think about it is whatever stresses we put on the body, then we're going to respond to those stresses and those stresses alone. So for example, if we're working down here on this part of the force velocity curve, again, just to make sure we're all on the same page, this is the concentric side only, right? So this is concentric contraction. Sorry, I'm using a laptop mouse here, which isn't the most conducive to this. So this is the concentric side of the force velocity curve from that image we just saw below. So the idea is if we put a bunch of stress where we're working in really, really rapid, fast velocity movements, the only adaptations, of course, then that we would see are, of course, going to be improvements in speed, quickness, and agility type movements, right? And the kind of opposite end of that. So if we look at strength training, right? If we're working with relatively heavy weights, the velocity which we can move these weights is going to be relatively low. Right? So here's our force here, velocity here, right? So our velocity is going to be relatively low. So you wouldn't imagine if we were in the gym lifting really heavy weights, then all of a sudden you would become an all-star sprinter. And if you were working in a bunch of plyometric exercises, that you would then all of a sudden become this strong man by being uh, really increased strength, right? So the idea that that this kind of graph is trying to get at is depending on where you work in this force velocity curve is exactly how you're going to see the adaptation. So if we work in the heavy force, low speed, of course, then that's going to improve strength. Right? If we think of power, right, we've defined power here as essentially force divided by time, right? And essentially the speed at which the contraction can occur. And so if you're trying to do powerful movements, right, you need a relatively large amount of force produced, but you need to produce it in a short amount of time. Right? So in that theory, right, it brings us somewhere here in the middle of the curve where we're working between 40 and 60%, halfway on the velocity, half on the force side of the curve. And that's how you're going to get better at power movements. And of course, as we move to the lower end of this, right, we're talking speed training, where the majority of the adaptations and are going to be in response to being able to do low force, high velocity movement. So one other thing that we'll point out is that as we move to the next slide, is that of course we can see these training effects. So here in the curve on the left, this is out of your textbook. So if you're still a little bit confused, you can go in and find this part in your textbooks. But here again, we've been training on the force side of the curve. So training for strength. So what we see is our 1 rep max here essentially is much higher, right? Our 1 rep max, sorry, terrible writing there. Our 1 rep max goes up because we've been strength training here with heavy weights. And again, we see no benefits really at all in the velocity part of the curve. If not, one of the downsides is maybe even a slightly worse off on the velocity side of things. So here, this is more of a speed training, right? So you're working at these low loads, high velocity, no effect on our 1 rep max or true strength output here, but our speed, velocity, agility type training has improved in the speed at which we can generate these movements. And we can see actually a slight improvement in the force that we're able to generate at the same velocities. Um, and so hopefully that breaks it down and helps explain the idea of the force velocity curve, and then how we can use that to determine what our essentially end goals for workout training is, and then how to select exercises on that force velocity curve to match those.